Oula, oula, oula. Everyone is coming. So this time is gonna be um, on Google Meet, because I think it's like linked with Google Classroom, something like this. So that's why. Uh, all right. We're gonna wait. Also, Victoria. Wait, wait, wait. So it's gonna be your first real boot camp. In fact, um, yeah. Um, stuk, 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 stuk. Message and we are live. What are you doing overall? Yes, yes, yes. Right. Okay. Right. Oh, wow. I have a lot of people to admit. Wait. My God. My God. My God. I was not ready. All right. So let's wait Victoria. Ah, Victoria is here. Could you hear us? All good.
Yes, I can.
All
Hello.
right. Perfect. Perfect. Okay. So I will manage people who want to uh, come into the call because we will receive a lot of ask requests. And yeah, so pretty exciting for everyone because as I said, as I mentioned, it's gonna be your first real bootcamp focus on solidity. Like a couple of you already done a few like session as a study group for ciphering in May. I think it was in May. I'm not sure. Yeah, in May maybe. um. So yeah, and actually we're gonna do that until August 7. And then at the end of the bootcamp, we're gonna have an hackathon at the end of August. This one is called Aleph hackathon. So it's supposed to be the biggest one in Latam. But like you can participate into it. I mean virtually. So we're gonna create team virtually, and also if you want, you can participate into it IRL, especially if you are in Latam, because they're gonna have like a couple of builder station, in every country, especially in Argentina. So yeah, just to let you know, after the Basecamp there is something. All right. Oh, sorry, I received a few requests to join. Yeah. Okay. Um. Definitively. All right. So what I wanted to say is like, yes, I'm gonna share my screen. It's gonna be better for sure. Before starting. Okay. Where are you? Okay, you are there. Let me share my screen. All right. All right. Okay. So normally, you have access to this interface. I will put the link again, but normally it's already on the email that you just received, like two years ago, 2 hours ago. Sorry. And then here you can find different things like attendance. So, for example, like yes, because we're gonna see who attend the the classes every time, that's gonna be better for us to check. Like we are not tracking really. It's just like to have an overview of the efficiency of the bootcamp itself. And then after each course, each courses, so you can find all resources there, etc., etc. Today is gonna be about introduction to blockchain, especially blockchain, Ethereum, and Superchain. Because Superchain is related to Lisk, Base, Celo, etc., etc. So we're gonna dive into that. And after each session, here you can find assignment. It's like homework that you can do until for be ready for the next session every time. So we're gonna have session from let me check until yes, until 7 August, as I mentioned, and here we have some session related to front-end development. So here, especially because a lot of you are front-end developers and wanted to really deep dive into that and how to really interact with blockchain when you are front-end developers. So that's why we have this biggest part. And it's kind of rare to have a deep dive into it. So you are really lucky to have it into the bootcamp. So yeah. All right. And after each session, for sure, we're gonna put recording here and also recording on YouTube. All good for everyone? I will just. A lot of people are waiting. All right, we are good. So I will let Victoria speaking. So I for those who just arrived, I just presented who singers walking into the boot camp. And at the end of the boot camp, we're gonna have an hackathon around 27 August. And this one is gonna be one of the biggest. It would be IRL and virtual. And yeah, you can see, you will be able to see it into the recording, like the missing part that you just missed. All right, all good. It's 2 hours by session, by the way. It's better to deep dive into things. All right, let's go.
All right. Hello, everyone. Hello, hello. It's nice to be here. All right. So let's kick off. Please just confirm you can hear me. Let me see like a thumbs up so I know you can hear me. All right. Awesome. Awesome. All right. My name is Victoria Adidayo. You can call me Vikish. I am a software developer, DevRel. I also do technical writing as well. So these are my social handles, so you can say hi to me on there. All right, so today's agenda, we're going to be talking about what is blockchain, understanding blockchain fundamentals, public and private blockchains, consensus mechanism, distributed ledgers, and you would also be talking about Superchain, how to set up a wallet, and also an intro to technical writing as well, because I believe that is a very important topic to talk about, because you need to know how to share your work and how to make people understand what you're saying as a developer. All right, so what is blockchain? So as a little break the ice kind of like activity. So let me see some answers on the chat before I start explaining, so I understand the level of understanding you have. So if you can just type on the chat what you understand by blockchain. So I'll be looking at the chat to see the answers. So when I say what is blockchain, what do I mean? What do you understand by it? There is no wrong or right answers. So all answers are correct, at least for today. This is the first class. So no wrong or right answers. All right. So a digital ledger, okay, digital decentralized ledger. Okay, recording transactions. All right, awesome. Where all the transactions are public, immutable, permissionless. Amazing. Awesome. Awesome. Okay, tamper-proof digital ledger. Great, great, great. Awesome, awesome. These are very, very nice explanations. So as we move forward, if you have questions, please do not hesitate to ask. We're all here to learn, and that's why you are here. So for this class, I'm going to imagine that you have no knowledge, and we're going to be starting from the basic, so that for those that do not understand can catch up and be on the same level with all of us. So if you have questions, do not hesitate to ask. All right,
Yeah, for context,
let's
actually,
get
like,
started. So
just to say, at the beginning, when they
yeah,
integrated Dev2Pack, they got like a discovery basecamp, and so we were focused on this area of basics, and so it's also well to review their review them.
that's lovely. That's awesome. Thank you so much, Celine. All right, so this is my own definition. It may not be the definitions that are in the chat, but it's still the definitions in the chat are correct, right? You guys did a lot um explaining that. So this is my explanation. So a blockchain is a decentralized distributed ledger that records transaction across multiple nodes in a secure and transparent manner. Secure and transparent manner. That is very important thing for you to note, is secure and transparent manner. It eliminates the need for intermediaries by enabling peer-to-peer transactions that are tamper-resistant and verifiable. I think someone mentioned tamper-proof, which is also very correct. So it eliminates the need for intermediaries, which means you do not need a middleman to perform transactions. You can perform transactions directly on your own. So blockchain gives you the autonomy, like you have the power to do transactions on your own, unlike your traditional bank that would, okay, yeah, your bank will make the transactions on your behalf. Because if you want to make a transaction, let me use an example, like your normal bank. If you want to make a transaction in your bank, you would, the way it works, right? You give the money to your bank, then your bank performs a transaction, performs some things under the hood, then send the money to the bank that's the money, the bank that you want to send the money to. So it's a bank performing the transaction on your behalf. But for blockchain, you are the one performing the transaction yourself. There is no middleman, there is no intermediary. You are the sole person initiating that transaction. So you have the power to do whatever you want. So it gives you that power over your transactions. And when we say it's tamper resistant and verifiable, that means that if you send, let's say, funds to someone and the person said they didn't see it, you can go to the blockchain to verify it. So it's verifiable, right? And when I say tamper resistant, is that you can't tamper with it. The data on the blockchain is permanent. So no one can go to the blockchain and change what is on the blockchain. So it's permanent on the blockchain. And yes, transparent, secure. The blockchain is very, very secure. That means we have multiple nodes. When I say nodes, I mean computers. We have a lot of computers all over the world securing the blockchain. So that means the blockchain is very, very, very secure. If it's just one computer securing the network or two computers, then we know that, okay, when those computers have any faults, then that will mean, okay, yeah, there's a problem in the network. But we have thousands and millions of computers securing the blockchain. That would mean that your data is secured. So even if 10 computers go down, like go down and them, your data is still very, very secure because we have a lot of nodes securing networks. So if you are a node, if you want to be a node and you're running a node on your computer, that would mean that you are contributing to the security and the health of that blockchain network. So that's what it means. And the characteristic of a blockchain is that it is decentralized. As I said earlier, no single entity controls the network. Transactions are verified by multiple participants, which are the nodes, as I explained earlier. It also immutable. Once data is recorded on the blockchain, it cannot be altered. It cannot be altered and it cannot be deleted, which ensures the integrity. So if someone tells you they perform a transaction on the blockchain, they cannot go behind your back and go and tamper with that transaction because they don't even have the power to do that. Even the creator of blockchain himself do not have the power to tamper with any data on the blockchain. So it is permanent. And yeah, it is also transparent, which means transactions are public. For public blockchains, right? Transactions are public and which enhances trust. So the participants of that blockchain can go and verify what's happening and stuff like that. And it's also secure. So cryptographic techniques, secure transactions. It also prevents fraud and unauthorized modification. So there's a lot of cryptographic mathematics going behind the hood for a blockchain to make it very secure. So in all, blockchain is a very secure, trustless, and transparent way to manage your data. No matter what data, it can be money data, it can be health data, it can be any data, right? Blockchain makes it very easy for you to manage your data for finance, healthcare, and supply chain management. It gives you a very good way to manage that data. All right, so how does the blockchain work? Because I've been saying all these things on how, okay, yeah, the blockchain is this, blockchain is that, but how does it work? How is it able to secure my data? How is it able to be decentralized? How is it able to be transparent? How does it work? So we have blocks, transactions, and chains that do all this. So a block is a collection of data that are recorded on the blockchain. So let me just click on this to give us a very deeper understanding. So let me just explain this. So a block is a collection of data, a collection of transactions that are recorded on the blockchain. Each transaction is verified by network participants before being added to a block. Blocks are linked together in a chain using cryptographic hash, creating a tamper-proof record of all transactions. So they are linked together like a chain. So this creates a tamper-proof way of managing transactions. So I'm just going to share this to give us a better understanding. So the slides will be shared. They're already in the classroom. So for those in classroom, you can find the links to all these here, but just for this, for if you want to follow, you can just check this out. All right, so just share the link to what I'm sharing. All right, so blocks are batches of transactions with a hash of the previous block in the chain. So these links blocks together in a chain. So like a chain, let me see, this is an example. So you see transaction 1, transaction 2, transaction 3, they are linked derived from block data. This prevents fraud because one change in, okay?
Yes,
you said something?
you were frozen, that's why.
Oh, okay. Sorry about that. All right, so this prevents fraud because one change to any block in history would invalidate the following block, as all subsequent hashes would change and everyone running the blockchain would notice. So it's like a hash. So what this means is that you are hashing the data of the blockchain. So this is why we say it is secure. So nobody can, let's say, nobody can decrypt the data on the blockchain. So it's hashed, and that makes it very secure. So to ensure all participants on the network maintain a synchronized state and agree on the precise history of transaction, we bash transaction into block. which means dozens of hundreds of transactions are being committed, agreed on, and synchronized all at once. So we have transaction in blocks. So you can see we have transactions in block. So you can see it here. So so how do block works? So to preserve the history, to preserve the transaction history, blocks are strictly ordered. Every new block creates a certain reference to its parent block. So these blocks are linked together. And for each block that is being added, a node have to verify that blocks. So it's a lot of mathematics and a lot of things going on under the hood. So for all this, so in summary, for me not to go too deep, right? Because if I go too deep, I can tend to confuse you guys a bit. So to all this just means that the transactions are being hashed. Let me share this back. So the transactions are being hashed, and a collection of those transactions are called block. So each transaction is verified by network participants before it is being added to a block. You know, I showed you what a block is in the other screen. So each of these transactions is being verified by the network participants, and the network participants that verify these transactions are nodes that I explained earlier. And blocks are linked together in a chain using cryptographic hashes, which creates a tamper-proof record of all transactions. So if you want to go deeper into how all this works, you can still go deeper into this, but this is just to give you an overview, understanding of how these transactions are being linked. So when you hear of blocks, you know that, okay, yes, blocks are a collection of transactions. You get? All right, so talking about consensus mechanism. So this is a very important concept to understand about blockchains. So consensus mechanisms ensure that all transactions on the blockchain are verified and agreed upon by the network. So when I say consensus, another word for consensus means agreement. So because the blockchain is decentralized, we created a consensus mechanism which helps us decide on which transaction is valid and which transaction is not valid. So, you know, we humans, we tend to disagree on certain things. So these mechanisms just create a very secure and a mechanism where all of us agree on certain data on the blockchain. So consensus mechanisms, yeah, I've explained that. So types of consensus mechanisms, we have proof of work, which is what is being used by Bitcoin. So miners solve complex mathematical puzzles to validate transactions. That's what proof of work means. So you give miners very complicated mathematical transactions to solve, and for them to be able to solve these transactions, they need a computer that has a very large amount of power, right? So the power of the computer have to be very, very high. So network. Yeah, so for you to be able to afford that that machine that has that enough power, so you have to, like, you know, invest in a lot for you to be able to afford that. All right, so I think my network is touching a bit. Sorry about that. All right, yes, because I noticed it's going off and on. All right, so proof of stake, right?
But when you have any questions,
sorry.
No, I said to everyone, like, when they have any question, don't hesitate to put it on the chat, and I will ask it to Victoria and India.
Yes, thank you. Please do that. All right, so validators are choosing for proof of stake. Validators are choosing based on the amount of cryptocurrencies they hold and stake. So there's a lot of things for us to go over today. Like, my slides are a lot, so I just want to go through them before I check the chat to see, like, the questions I have. So I'm going to pause for a bit to see the questions I have. So if you have questions, please drop them on the chat and I'm going to check them. All right, so validators are choosing based on the amount of cryptocurrencies they hold and stake. That is for proof of stake. So the amount of cryptocurrencies you hold, that's how validators are like choosing. So for Ethereum, you have to take the minimum of 32 ETH. You can stake more than, but the minimum you can stake on Ethereum is 32 ETH. And so other mechanism, delegated proof of stake, we have those. We also have proof of authority. We also have the Byzantine fault tolerance. Funny thing is, when I was actually starting out, I checked out. You should actually check out this Byzantine fault tolerance. It's actually very interesting because it follows this military way of consensus mechanisms, and it's very, very exciting. So you should definitely check it out. All right, so the questions I have: can a real application of this be something like Remitter? Although that uses real banks, yeah, traditional banks. Yeah, so creating something like Remitter on chain is possible, right? We actually have that. We actually have some versions of this, but not exactly Remitter, but we have some versions of this. So for those that do not know what Remitter is just a means of payment, right? It gives you very nice, so it's actually based on Web2. So if blockchain stores all the transaction, where is the smart contracts stored? So the smart contracts are also stored on the blockchain. A smart contract is a data, like a smart contract is a transaction on the blockchain. So when you want to deploy a smart contract on the blockchain, you have to make a transaction on the blockchain to store that transaction. So in your next class, your tutor is going to take you through how to deploy a smart contract. So when you deploy that smart contract, you go to the blockchain and you confirm that. You see that that smart contract is actually a transaction on chain, but it's a different kind of transaction. It's a different type of tag. So it's going to have something like contract deployed or something of that sort. Yes. Thank you so much, Etiti. All right. All right. So let's move forward. We have a lot to cover. All right. So nodes and clients. I was explaining nodes earlier. So sorry about that. So nodes are computers that store a copy of the blockchain and validate data and transactions, right? So nodes are computers that store a copy of the blockchain and validate transactions. So when you want to think of nodes, just think of computers. Miners in proof of work, POW means proof of work, or validators in proof of stake. So in proof of work, we call them validators. So they are responsible for verifying transactions and adding new blocks to the chain. So when you make a transaction on chain, just know that a node is in charge of doing that. So a node is in charge of doing that. Light nodes rely on full nodes for information. So let me just click on this. So I added links so you can easily read more on this because the slides do not give you enough information, right? So a node that is connected to other computers also running Ethereum software, forming a network. So what a client is the implementation of Ethereum that verifies data against the protocol rules. So the client is just like an implementation of the blockchain, or in the case of Ethereum, a particular implementation of a particular part of the blockchain. So we can have an implementation of the consensus, an implementation of the execution clients, and stuff like that. So a client is the implementation of that. So a consensus client, we have a consensus client and an execution client. So you can read more on that. So since I've been talking about nodes, let's read more on nodes. But if you want to go deeper into clients, you can check them out because we have execution clients and we also have consensus clients. So for a consensus clients, the consensus client is the one in charge of consensus. Anything concerning nodes, anything concerning staking and all those stuff. So a consensus client is in charge of that, but an execution client is in charge of your transactions, executing your transactions on the blockchain. So that's what an execution client is for. So for nodes, we have different type of nodes. We have full nodes. So if you want to run a node, you should definitely check all this out. So for full nodes records the information of the transaction block by block. So it validates the transaction of the on the blockchain block by block. So you also, sorry, give me a sec. So participants in the block verifies all blocks, and all states can either be retrieved from the local storage or like all that. So it's, yeah, this is what I was looking for. So full nodes only keep a local copy of relatively recent, let me do this. So full nodes only keep a local copy of relatively recent blocks, typically the most recent 128 blocks, allowing older data to be deleted to save disk space, because there is a lot of disk space and a lot of space, computer space involved in running a node. So if full node deletes all data and just stores the most recent 128 blocks. But for archive node verifies the block and stores the block from the genesis, from the one. It stores it from the genesis. It stores everything. I think there's a place. Yes, this is it. So stores everything kept in the full nodes and builds an archive of historical state. So right from the Genesis block means the first block that was created on the blockchain, the first block. It gives you all those data. So the people that run archive nodes are mostly chain analytics and all those people that run a lot of big data, block explorers too as well. So they run archive nodes, and wallet vendors, wallets like MetaMask, they most likely run their own archive node, or they have someone that provides that service for them. So light nodes are mostly used for so light nodes give you the block headers, right? Gives you the block headers, only like the small information that you need from the blockchain. So this is mostly needed for mobile phones and for your iPads and for your devices, your small devices. So that's what most people use light nodes for. So as that on nodes, so let me do that instead. All right. So public and private blockchains. Public and private blockchains. So one feature that you should note is access. So public blockchain is open to everyone, while private blockchains are restricted to selected participants. So take note of it. Public blockchain is open to everyone. Private blockchain restricted to selected participants. Most times I wonder, like when you say blockchain is private, why should a blockchain be private? Like it's I feel like it's contradicting the whole blockchain is public thing we have. But private blockchains, you can also call them permission blockchains. They are needed for certain information, certain things that you need on the blockchain. Private blockchains are needed for that. So for control, public blockchain is decentralized, while private blockchain is semi-centralized. And when I say semi-centralized, is that just a few participants or group have control over it. So they decide what happens on the blockchain. Private blockchains do not have DAOs. I think they do. I think they do, but their DAOs are also restricted to certain people. Like their DAO is not, it's not a DAO, like it's not a DAO that we know that, you know, in public blockchains. So that's what I would say about that. So for security, they are secured by
they don't know what is DAO.
so, okay, yeah, that's
they don't know what is a DAO.
that's true. Yes.
Just to let you know.
Yes. So a DAO is a decentralized autonomous organization. When I say a DAO, let me type it on the chat. A DAO. So a DAO is a decentralized autonomous organization. So it's the one in charge of for us to make certain decisions on the blockchain. So for a that makes involves everyone on the agreement and what happens on the blockchain. So it means to participate on the decisions that are being made on the blockchain. So let's say, for example, the blockchain wants to make certain decisions, so you use a DAO for that. So I think I should actually give you a visual understanding of that. So on Leaks, we have a DAO, and there's a proposal that is currently ongoing, and I think you will find that interesting. Let me just open it up. So it's a very, very interesting conversation that has been happening. Sorry, leaks.com. Okay, it's opening up. All right. Share this instead. So, all right. All right, so this is what a DAO looks like. This is the visual presentation of a DAO. So when I say a DAO is being made to, a DAO is used to agree on certain decisions that are being made on the network, because we said a DAO allows you to have ownership and participate in what happens on the blockchain. So it gives you that avenue to be able to cast your vote on what happens on the blockchain. So there is oh my gosh, I just saw this. All right. So this is a proposal that has been happening currently on the blockchain. So you have lists of proposals, and you have, so this is a proposal that is currently being had on the blockchain, so on the Leaks blockchain. So they are saying, should 1 million LSK of the DAO treasury be burned? So this is a decision that needs to be made, and the community needs to make that decision. So this was proposed on July 1st. So you can this means quorum was not reached. Yeah, you have to do it again. But yeah, so these are the four. The four is in green. These are the people that are for the timeline, and those that is the timeline, and those that voted on it. So you can see those that voted, and you know what they voted for. You can see those that voted against, and you can see those that voted abstain. Right. So yeah, there's something I wanted to show. So let me just click on this person that has the most delegates. So for a DAO, you can actually like delegate your vote, but let's not go there. Let's not go there. But what I mean, the whole thing about the DAO is that the DAO is where decisions are being made. So you can you can propose for, or you can propose against the decisions that are being made. So anybody can come here and vote. Anyone can come here and vote, as long as you have staked certain amounts of token. So stakers can vote. As long as you are staking, you can also vote. And if you do not want to vote, or if you don't, if you have a token and you do not want to be part of the people that would, you know, vote on the DAO, you can just delegate your vote to someone. So your voting power. So your voting power allows you to sort of have kind of like the decision, the power your vote has, right? That's your voting power, the power your vote have. This person has 3.9 million voting power on LSK. So the LSK you have determines how much voting power you have, right? So this person has received 435 delegates. That means 435 people have trusted this person and delegated their voting power to him. That means their LSK, they delegated their token to him to trust his own decision and what he stands for, basically. And yeah, I think this is it. We also have community on the DAO and stuff like that. So you can check this out. Let me send this to the chat so you can take a look at it for that. So we'll not spend too much time on it. All right, so for bond, this decision means they want to burn 100 million LSK. So when you burn a token, you take it out of circulation. That means that token ceases to exist. Like it's gone. It's gone. So they are asking if they should burn 100 million LSK. So when you burn a token, there are certain advantages, right? The token is gone forever, but that also increases the scarcity of that token. So when a token is scarce, it increases the price of that token. So if the token is a certain price, when you burn it, the price increases. So this was what they are trying to say. And for this decision, right, let me just say more on it. For this decision, when they burn 100 million LSK, yes, the price of LSK is going to increase a bit, right? And if they don't burn it, they can invest it in certain decisions or certain innovations or certain things that are going to happen on the DAO. Let's say incentivize builders on leaks and stuff like that. So it's a very tricky vote and a very tricky time for the leaks ecosystem. So I would advise everyone to be a part of it. You can vote, you can delegate your vote, anything you want to do. And if you need more information on it, you can check out Leaks DAO on X. And yeah. Are there no attacks on DAO where people create fake accounts multiple times to vote? How do they stop those people? That's a very good question. So okay, so when you create multiple accounts to vote, so the thing with DAOs is that people need to trust you to be able to delegate their LSK to you. So if I do not trust you, I would not delegate my voting power to you. So for all these people that you see that they have high voting power and people delegate their LSK to them, it's because they trust them. They trust that these people, they know them, right? These people are people that we know on the community. They make certain decisions. They have decisions on what happens on the blockchain and stuff like that. So these people are not quiet. These are people that we know on the blockchain. So let me just. So this is a discussion channel for the DAO as well. So you can see certain decisions that are being made as regards the DAO. So these are people that you know. Before you delegate your LSK to anyone, you should come here and check what they are saying. So if what they are saying makes sense, right? If what they are saying makes sense, this if you go through this was a should burn or invest the 100 million LSK. So you can check them out. Check their views. If their views align with you, then go ahead. And if you would want to be if you want to be someone that they would delegate to, right? Yes, you can be like coming in a sec. Yes. So you can come here and just like be someone that would, vote certain decisions and you stake a proposal and, do certain things. So you can just come here and do that. So it depends on if you want to do that. So it's your choice. So if you want people to actually delegate their LSK to you as well, you can do that. So you just have to have certain reputation on the DAO and you on certain things. Yeah. Let me see if there are any questions. I feel like we are spending so much time on this, but it's a very interesting conversation.
Yeah, totally. So thank you for the
Yeah.
highlight. I think it's an important topic. Yeah.
All right. Yeah. All right. Okay. Good. So we can move on. Yeah. I think this is a very interesting one. So if you want to learn more about it, DAO, you can check it out. Check it out, be a part of it. It's a very interesting thing. So that is why Web3 is very much liked, because it gives you the power to decide what happens on like a network. So your governments they do not give you, they do. Elections, elections happen. So just see the DAO as an election that's happening on certain decisions. So let's say let's view this. Let's say your government wants to build schools, right, or hospitals, and they put out a proposal. and say, okay, they want the citizens to decide how many schools and how many hospitals they should build, and if they should even build that. So they will give you how much they want to use that for, and you would be the one to, like the citizens, you'll be the one to decide, okay, this is what I want to happen, this is what I want to happen, and stuff like that. So that's what happens. The government of these days, they don't do that, but yeah, that's what should happen. But yeah, it's not happening. Yeah, okay. All right, so we've diverted a bit. Let's come back. Bitcoin, Ethereum, and for private blockchains, we have Hyperledger and Cordia. So you can check them out. Hyperledger is a very popular permissioned blockchain. So permissioned and private blockchains are the same thing. So you can check them out. All right, so cryptography and security. So let's talk about that. So hashing and digital signature. So that was why I didn't want to go into hashing too deep then, because I know we are going to talk about it here. So hashing converts data into a fixed length string, ensuring data integrity. Even a small change in inputs creates a completely different hash. A small change in inputs creates a completely different hash. So a hashing converts data into a fixed length of string. That string is, so let's say you have a hash of your name. Let me see, whose name should I use? Okay, let's use Joy, Joy. So let's say you hash Joy, you hash Joy, and you have a certain length of a certain string of like numbers and letters and combination of all that. So let's say you changed Y to a different letter. The hash will be completely different. That is, you have a different hash altogether. So a different input results in a different hash. So digital signatures are cryptographic keys used to verify the authenticity of transactions, preventing fraud and forgery. That's what digital signature is. So that is why the blockchain is very, very secure. So for a transaction to be able to happen, for any funds to be able to leave your wallet, right, you need a digital signature for it. So you have to give your digital signature and say, okay, this is my signature, verify this, right? Verify this, do this and do that. So for example, now I have yeah, so just see it as a key, right? Is a key. So you give the person the key and say, okay, this is the key for. So if you have a box at home, if you don't give anybody the key, they won't be able to access or go through your belongings, right? A key to your house, or for instance. So if you don't give someone the key to your house, they won't be able to access it. So that is the same way digital signature is the key to your funds, a key to your USDT or USDC or anything you have on chain. That is what your digital signature is, right? So it is used to verify the authenticity of the transactions on chain. All right. So for a wallet is a means of managing your data and performing transactions. So a wallet just gives you a way of managing transactions on chain. So it just gives you a very nice interface of approving and managing transactions and managing your funds on the blockchain. Let me go back here. Okay, yeah. So this is from Ethereum book. So this gives you a very deep understanding on cryptography, keys and addresses, and everything about how it works, right? So gives you a very good understanding of what it is. So let me looking for something. Give me a sec. All right. So let's talk about keys and addresses, right? So public key cryptography is called asymmetric cryptography. So let me increase this a bit. Yes. So public key cryptography is also called asymmetric cryptography. So it's a core part of what's like the key information of security and everything. So cryptography is not only used in the blockchain, just for you to understand. Cryptography is used in other parts of your life and things that you don't even expect that they're being used for. So all right. So you have all right. So we have so public key cryptography uses unique keys to secure information, as I explained earlier. So these keys are based on mathematical functions that have a special property, and it is easy to calculate them, but it is hard to calculate their inverse. So when I say inverse, it is the inverse of like what they were before. So let's say I give you 2 plus 2. 2 plus 2 is 4. But when I give you 4, you won't be able to determine what gave me 4. That's what I mean, the inverse. So it is easy to calculate them, but it is very, very hard, almost impossible to calculate their inverse. That's what it means. So that's what public keys are. So let me see.
Do you
I
have
don't
like
want to go.
a graph or something
Okay.
like this, something more visual, probably
Oh yeah,
to
yeah, yeah.
yeah.
Yeah, we are getting there actually. We are getting there.
Oh,
So let me think there should be graph something here, but let's just go at it little by little. We're going to get there. So a more advanced category of mathematical function that is useful in cryptography is based on arithmetic operations on an elliptic curve. And that's what I'm going to explain in a bit. So in elliptic curve arithmetic, multiplication module is a prime in simple but division. That's the inverse of all this. So elliptic curve cryptography is used extensively, right, in Ethereum, everything you know about Ethereum, that's what it's being used. So Ethereum uses elliptic curve for private keys and your digital signature and like everything I explained earlier. So in Ethereum, we use public key cryptography to create a public private key pair. And a pair is because the public key is derived from the private key. So you can get your public key from your private key. So that's what it means. So you get your public key from your private key. So together they represent an Ethereum account, providing respectively a publicly accessible account handle, which is your address, right? I'm going to give you a mathematical question that is going to make this easier to understand, but just follow me very gently, right? So, and private control over access to any of either in the account and over any authentication an account needs when used in the smart contract. The private key controls access by being the unique piece of information needed to create your digital signature, which are required to sign transaction and to perform any transactions on the or wallet or anything that on the blockchain or anything you need for. So it's also needed to remove funds from your account as well. So let me come here. I think we've done too much of that. So this is a randomly generated private key, right? This is a private key. This is what a private key is. So let me come down here. So this is the elliptic curve, and the elliptic curve is a type of asymmetric or public key cryptography based on the district logarithm problem as expressed in additional. I don't want to do too much of this. Okay, yeah, this is where I'm going to. So the public key is calculated from the private key using elliptic curve multiplication, which is practically irreversible. So you have K, which is your public key, equals to small letter k times g. G is the point on where around this place. So where K is the private key and G is the constant point called the generator point. So K is the resulting public key, and this times here is a special elliptic curve multiplication operator. That's what they use like on the elliptic curve. If you don't understand, please follow me gently. I'm going to make it clear in a bit. So note that the elliptic curve multiplication is not like multiple multiplication. It shares a functional attribute with normal multiplication that is about it. So for example, the reverse operation, which would be division for normal numbers, known as finding the discrete logarithm of calculating K. So if you know what K, remember this capital letter K is your public key. So K is as difficult as trying all possible values of K, a brute force search that will likely take more time than a universe, blah, blah. So you cannot even do it. Like some people would want to. So let me just come down here to give a very good example. I think something like that should be somewhere here. Yes, this. So some people would want to, okay, let's say they want to calculate what small letter K is from this capital letter K. You won't be able to do it. That's what this was explaining to us. Like it's almost an impossible task to be able to perform. It's almost impossible. Like you won't be able to do it. So it is as difficult as trying all possible values of small letter K, which is your private key, a brute force search that will likely take more time than this universe would allow for it. So it's almost impossible for you. It's almost impossible for you to find your private key from your public key. So your public key, your address is being generated from your public key. So your address on MetaMask, for example, now, your address on any wallet on the blockchain is being generated from this K. It's being generated from your public key. That's just what it means. So that is being generated from a public key. So this is what it is. So starting with a private key in the form of randomly generated number K, we multiply it by a predetermined point on the elliptic curve called a generator point G to produce another point somewhere else on the curve, which is corresponding public key, which is capital letter K. So we just calculate a generator point and we get the corresponding public key. So it changes all the time. So that's why you have different calculations for your public key from every private key that you use. So even the generator point is the same thing for each one. It's the same thing. So it's the same thing. It's the same thing. You can see it's multiplied by a predetermined point on the curve called the generator point D to produce another point somewhere else on the curve. So the point that it produces is this one, which is your public key. So in all essence of this, what I'm trying to say is that when you give someone your address, they would not be able to calculate your private key from it. Even if you give them your public key, even if you give them that, most wallet address will not give you your public key. They only give you the last 20 digits of your public key, which is fine. That's what you need either ways. But it's almost impossible. Even if you want to calculate it to the end of the universe, it is not possible for you to be able to get public key. So do not be scared to send your addresses to anyone that you want to send it to. So they would not be able to get your private key from it. So for you to understand, if you want to really go deep into this mathematics, it's very interesting actually. It's very interesting. If you want to spend more time on it, was actually like spend almost the whole day, but it's almost impossible for you to do that.
Yeah.
So let me have questions.
Just to let you know,
Yes.
like we're gonna have later in today's Tripag a Builder Club related to cryptography itself. So no worries.
Okay, that's awesome. That's great. That will be very, very interesting. That's awesome. Let me just share this. So I actually thought I shared it. So sorry. So I just shared it. So it's the Ethereum book. No, cryptography is actually very interesting. Like it's super interesting. So if you want to, I would advise you spend more time studying it, right? It's very interesting. So funny thing is some people actually study cryptography, like that's what they do. For you to create a blockchain like Ethereum takes a lot of work. So those that study cryptography, they are the one that creates blockchains that you know as like as Lakes, Celo, Base, all these blockchains. These are the people that create them, right? These are the people that create them. Yes, ZK. Yes, thank you so much. ZK is very, very interesting as well. Yes, never share your private key, but you can share your address. You can share your address because you know that your address is being derived. So let me look for that point. There's a place where that is being said. This is a very, very lengthy book that gives you all the whole information that you need. I think there's a place where that was being said. I think I've passed it. Okay, yeah. This is the calculation. So this is your private key. This is the generator point. So you can see this is how it's been derived. This K is your public key. So you can see how it's been derived, which is very interesting. So there's a lot of mathematics and calculation that goes into this. So for your public key, the last 20 bytes of your public key is your address. So you can get your address from your public key. So it's very easy to calculate that. So it's a calculation that's been done as well. I was looking for where they said that, but I can't find it anymore. Why? But yeah, you can go through this, read more on this, so you really understand how it works. But it's a very, very interesting concept. So a private key can be converted into public key, but a public key cannot be converted back into private key because the math only works one way. So it's a one-way mathematics. It's a one-way mathematics. And someone was asking what is logarithm. So logarithm is just a term in mathematics. That's what like logarithm means. It's just a term in mathematics. But let me just remind myself what that is. Give me a sec. Yeah, so it just refers to logarithm, just refers to like mathematics. So yeah, just like a term in mathematics. All right, so that was a lot to digest. I'm still looking at the chat if you have questions. Okay.
Just something, comments. So you can on Google Classroom, actually you can tick a box to say you were present at the session. Just to let you know.
Yeah, I think that should be opened already. I don't know. I don't know if Itete is still here.
Yeah, I believe it's open.
All right, okay. Thank you. So for those that are on the classroom, you can go mark your attendance. But let me share my screen to explain just a bit before we continue. Okay. Yes, so it's open. So you can just come here and we already have people marking their attendance already. Awesome, guys. So you just come here and click present. So if you're not on the classroom yet, please let us know so that Solon will add you to it. I also have assignments already for you, so you can check it out. That's your assignment for today. But I'm going to say more on the assignments at the end. So let's continue. All right, private key, public key. We've explained this already. Yes, smart contracts and automation. So smart contracts are self-executing programs stored on the blockchain that run when predefined conditions are met. So they remove intermediaries, automating agreements and reducing costs. And use cases, DeFi, NFT, DAOs, use smart contracts is a very, very important part of DAOs. We also use it in decentralized finance. We also use it to deploy NFTs, create NFTs, supply chain management, healthcare, a lot actually. So blockchain security relies on cryptography, centralization, and transparency to ensure trust and integrity in digital transactions. So they are self-executing programs. So when I say self-executing programs, so they are being executed when a certain condition has been met. So let's say somebody evoked a transaction, or somebody evoked it to, so it's an automated or automated kind of like program. So it's self-executing. So when you put it on chain, all a user needs to do, you don't need to do much anymore, right? All user needs to do is just to go there, perform their transactions, and stuff like that. It's automated. Like they just need to interact with the smart contracts. That's all. You as a smart contract programmer, all you need to do is create a smart contract that is very secured. Then a user would now go there and perform their transactions and everything. You don't need to do much. All you need to do is manage the smart contracts, and yeah, very important. So I have a question. So is it possible for a smart contract to be hacked? Because we've spoken about like how the blockchain is very secured, or the cryptography involved in your addresses and performing transactions. So is it possible for a smart contract to be hacked, considering how secure the blockchain is? Okay, yes, it's possible. No, 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 no. Okay. So somebody said yes. So the person that said yes, let me see. Somebody said yes. So the first person that said yes, Harshit Shauhan. So if you can unmute your mic and tell us why you feel it is possible for a smart contract to be hacked. We are curious. Why is it possible? Or you can, if you can't talk, you can explain it in the chat. Okay. Okay. Yes, when 51% of the network node is hacked. If the code allows something malicious, then okay. This is very tricky. All right. Okay. Okay. Awesome. So we have, all of you are saying, okay, some people are saying yes, some people are saying no, that smart contracts cannot be hacked and stuff like that. So a simple response to this, brute force anyway. Okay. All right. Awesome. Okay, so this okay, let me just explain. Right. So a smart contract can be hacked. Yes, it's possible for a smart contract to be hacked, but it is not the fault of the blockchain. It is the fault of the programmer that wrote the smart contract. Yes. So if a smart contract is hacked, it is your fault as a programmer for allowing that smart contract the blockchain. That is it. Yes, exactly. If they have vulnerabilities, that's true. That's true. So someone explained it exactly. So someone explained it actually, and I liked that explanation. Let me look for it. Okay. Yes. So Selena, she said, oh, they said, I don't know if that's a lady. So if the code allows something malicious, then yes, it is by design. Yes. So it is the fault of the programmer that a smart contract would be hacked. Yes. Awesome. Awesome. Thank you so much, guys. These are very amazing responses. So yes, a smart contract can be hacked, but it's the fault of the programmer that wrote something that can be hacked. And more often that you can imagine, smart contracts are being hacked more often than you can imagine. It's very, very possible. It's sad, really, but yeah, it happens. It happens a lot, a lot. So you as a programmer, you have to be very careful and really understand what you are writing. So for your next class, I would advise you to pay very good attention to what your facilitator is saying, so you really understand it, because some people will just learn what is smart contract and immediately paying smart contract code. That is not what you as a programmer should do. You should understand what you're writing very, very, very well, because attackers are roaming around looking for vulnerable smart contracts to hack. So that's what they are looking for. So you do not want to be a victim, right? You do not want your users to be a victim to such, right? Because it's very painful when you as a user trust a smart contract programmer to program something very secure, and then you end up with a smart contract that can be hacked. So it's advisable to test your smart contract. Test your smart contract. A famous library used for testing smart contracts is Foundry. So it's advised you do that. Test your smart contract. Test your smart contract. Very, very, very important. All right. Okay, yeah, I think we've done this already. All right, so uses of dApps. So a dApp is simply a front end plus a smart contract. That's what a dApp is. So when you have your front end, you have HTML, CSS, or React, then merged to a smart contract. That's what we call a dApp. So a dApp is a merge of a front end plus a smart contract. That's what it means. And yes, so we also have different type of dApps. We have Uniswap is a dApp. Yes, Aave is a dApp. OpenSea is a dApp. A lot of dApps are actually. So if you know of any dApp that is not being mentioned, you can see them in the chat. There's a lot of dApps that we have. A lot of dApps. So you also have NFT marketplaces. OpenSea is an example of an NFT marketplaces. We also have gaming dApps that they use for gaming. A lot of gaming applications are being built mostly on Stacknet at the moment, right? So we also have supply chain management. So this enables you to track logistics, where your packages are being going to. So if you send packages to other countries, just know that you can use blockchain for that. So you can use blockchain to verify certain things. So blockchain can also be used to verify receipts or verify information on chain. So you can also use blockchain to store or save your certificates or something like that. So you can build a dApp that enables people to save their certificates on chain. Then you can charge them monthly or yearly for your services. This is an idea of a dApp that can actually do well. So it's going to be like the Google you have, right? Your Google cloud storage that you have. That's what it's going to look like. All right, let's go. Okay, challenges and limitations of the blockchain and how we solve them. We have few, just have to rush this. All right, so we have the blockchain has different challenges, right? There's a lot of challenges on the blockchain. So for the blockchain is decentralized. It is secured. Think trilemma. That's what it is. Trilemma. I think I should be able to find the triangle. Give me a sec. I should actually include the image, but I think that skipped my mind. Okay, so it's called a trilemma problem, right? So the problem of the blockchain is called a trilemma problem. So the blockchain is decentralized. It's also secured, right? But it is not scalable. So that's what we call a trilemma problem on the blockchain. So that's what we're currently facing. I'm trying to look for like a triangle that explains it, but not finding it. But just picture a triangle. So something like this, something like a triangle like this. So that's what it is. So this blockchain is decentralized. It's had security, it's very secure, but it's not scalable. Most times the scalability is at the top of the triangle here. So we have decentralized here, security here, but it's a problem on the blockchain. So a way to solve this is, and the reason why we have the trilemma problem, the reason why we say the blockchain has scalability issue is because blockchain networks struggle with slow transactions and speed, and also high gas fees due to network congestion. So a good way I like talking about it is I feel, right, it's actually true. Actually, the creators of the blockchain did not picture this much adoption, right? They did not foresee this more adoption on the blockchain. So they did not anticipate that, okay, they're going to need certain things, or they just wanted to solve the problem that we were facing at that point, and they ended up with a scalability issue, and which is as a result of which causes slow transaction speed, because you have millions of people trying to make transactions on a blockchain that does not accommodate that many people, right? Which also results to high gas fee, because validators would want to attend to someone that would want to pay at least $100 for like a transaction. This is just like an example. So for example, now you as a validator or like a node runner or something, so you have like tons of transactions, right? So, and you have someone that is willing to pay $100 and others are giving you $5. Who are you going to respond to? So definitely I'm going to respond to the person that can give me $100. So that's what causes the high gas fee that we were facing previously. So this is a previous issue. This doesn't happen anymore because thankfully we have layer twos, right? We have layer twos like we have two different types of layer twos. We have optimistic roll-ups. We also have ZK roll-ups. So what layer two does, so just like a second layer of the blockchain. So they build a blockchain on the main blockchain. So the main layer one blockchains are like Ethereum. So you have a layer two blockchain that is being built on top the layer one. So a layer two, a roll-up, layer two blockchain is also called a roll-up. So to improve the speed. So most the main cause of the reason why transactions are slow on the blockchain is because a lot of transactions are being run. So they just decided that, okay, since the reason why transactions are being slow is because a lot of transactions are being made on the blockchain at the time. So why not just we bash all these transactions and like execute them off chain. So that's what they do. They execute those transactions off chain and bring those transactions that they've executed on chain to be validated on the layer one blockchain. So instead of you doing all the processing of transactions on the layer one, you do it on the layer two that is very cheap. So they kind of like bash a lot of transactions. So they can bash, let's say, for example, 1,000 transactions, they can bash it into one and validate it on layer one, which is very, very much cheaper than everybody just running their own transactions on their own. So since the transactions have been executed already off chain, they can just bring it on chain to be validated to be sure that those transactions are valid. So that's what we do on rollups. So that's what rollups do.
Yeah.
So
like 2 years ago, it was just crazy to use Ethereum as a like layer one to process the transaction. It was like too much high fees. Like we say, like if you want to do like a transaction, it was like $10 of fees, something like this, or just a crazy amount. So it was not possible to use this blockchain anymore. So that's why layer two we're there to provide this cheaper transaction fees. Yeah.
True. It was actually crazy that I myself, I made a transaction of $12. I paid $12 for just a one transaction. I was very pained. And it was crazy because I did not know that okay, there's something as like a layer two or something that I can use. I paid $12 for a transaction. Like, that's very crazy. And funny thing, it was a $20 transaction. I paid $12 for that transaction. It was very painful. So please do not use any layer one, please. If you want to, don't use any layer one, use a layer two. They are very, very much very, very cheaper. Like for example, on Leaks, your transaction is less than 0. Like very cheap, $0.02. Very, very, very cheap, very insignificant. You will not even know that okay, this is a fee that you are like, because on Leaks we actually like one of the cheapest layer twos out there, like very, very cheap to make transactions on Leaks. So please use layer twos. Don't be like me. All right. So we also have the issue with energy consumption, which is the proof of work, where it's very, very massive. It requires massive computing power. So which means that it consumes a lot of energy, and you have to pay a very high electricity bill. There are people that still do this actually, but yeah, people still run Bitcoin nodes, but these are very, very so that's why we have proof of stake. So it replaces mining with staking and stuff like that. So we spoke about this earlier already. So these are the types of blockchain. So we now have green blockchains as well. So proof of stake, yes. So we also have green blockchains like Algorand and Tezos. I don't know if you guys have heard of them, but yeah, they use green energy instead. Very interesting stuff. You can check them out. Another issue we also have on the blockchain is the government. So governments struggle to regulate decentralized systems. So it's something they've been struggling with for a while now. But now we have clearer regulations on the blockchain. We have many countries developing frameworks to help aid blockchain regularization in each countries. And then we also have for that helps governments to kind of like validates that okay, some people just open wallet addresses on MetaMask, but you don't know who they are. So for governments to be able to regulate blockchain transactions and blockchain as a whole, we need something like this. So that's why we have a lot of things like this. You have Gitcoin Pass, you have like a lot of them like this. So yeah.
There's an interesting question about processing transaction of chain. Probably you can think about ZK. Like, Donia put like, I'm confused. Blockchain is used because it's secure. Is you use layer 2 to process transaction of chain outside of the blockchain? They are still secure. There's like a specific mechanism around ZK for when something is secure.
Oh yeah, sure. So let me just read that again. So blockchain is used because it's secure. Yes, that's true. So we have layer 2s to process transactions off chain outside the blockchain. Then are they still secure? Yes, they are very, very secure. So they use very secure computations, right? So same as the blockchain, right? They use this means to especially for example ZK rollups. These are so complex mathematics that have been so the mathematics I explained about how a blockchain is being created, more like this is being used for layer 2. So layer 2 is also a blockchain on its own. just for you to really understand, layer 2s are blockchains on their own. So they use all these cryptographic mathematics, all these things to secure their transactions. And now we also have that use zero knowledge proofs to make sure that the transactions are being validated and executed. So just give you the way of executing transactions. So you can take a look at this rollup. So Stacknet is an example of ZK rollups, while optimistic rollups are like another examples of rollups and how they manage transactions. So how just imagine how Ethereum is very secure. So layer 2s also benefit from the security of Ethereum. So Ethereum is very, very secure. So they benefit and they kind of like fetch from that security of what Ethereum provides. So and you also ask if they are secure. Yes. So when a transaction is being run on layer 2, right? For example, when a transaction is being run on leaks, has been executed on leaks. So for that transaction to be valid, those transactions are bashed, then sent to Ethereum. Now Ethereum will now validate those transactions. Like Ethereum do not just accept any transaction from any layer 2s. No. Yes, layer 2s are secure. They execute your transactions securely, but Ethereum itself does not trust 100% that the transactions that the layer 2s are giving to it are secure. They validate them to be sure that these transactions are valid for them to be able to even add them to like layer 1. So when you run transactions on Stacknet, you see something like transaction processed on on Stacknet, then you now see validating transactions on L1. So it takes a while for those transactions to even be validated on L1 because Ethereum has to do a lot of validations to be able to be sure that these transactions are valid. They have to run some computations to be sure that those transactions are valid. So the fact that we have layer 2s do not mean that the security is being reduced. In fact, we have more security because layer 2s do theirs, then layer 1s also do theirs as well. So they are benefiting from two security source. So yes, that's what that means. That answered your question. All right, so we're almost done. I'm going to run because we are far behind time. So what is the Superchain? Superchain is a growing network of blockchains that are built using a shared standard code base called the OP stack, which allows this blockchain to interact in ways other blockchains cannot. So let me just pause a bit and talk about interoperability problems. So I spoke about we have scalability issues and other issues that the blockchains are facing. So the blockchain also faces interoperability problem. So interoperability problem is like an instance where leaks cannot talk to base. Stacknet, let me not go to Stacknet because Stacknet is a ZK rollup. So let me talk about optimistic rollups now. We have blockchains that cannot talk to themselves, and it's very bad because we have blockchains being separate. You have blockchain being separate and my own, this is mine, this is mine. This is not the future we imagined for blockchain. No, that is not the future I imagined for blockchains. We want a future where blockchains can communicate, blockchains can interact, blockchain can process transactions together and not against each other. We have blockchains should be interacting with themselves and not against each other. So Superchain brings a network where blockchains can interact with their self. So blockchains on the Superchain, right, they are built using a shared standard code base called the OP stack, which allows these blockchains to interact in ways that other blockchains cannot. So blockchains on the Superchain can interact in ways that other blockchains cannot interact. So optimism is a whole lot more than a single chain. the superchain is part of the optimism ecosystem. So when you hear of optimism, you also talk about superchain, because optimism created superchain. Optimism just realized that, okay, there should be a way that blockchains can interact and work together as one. That's why they created superchain. So let's move forward. So the current issues we face in interoperability between blockchain networks, that these are the issues that Superchain is trying to solve. So we have isolated blockchain networks. We have where blockchains are isolated. They are not working together. They're just on their own, which is not the future we want. We also have lack of universal standard, where there is no standard for building blockchains. Every blockchain just comes up and build theirs. We have thousands of blockchains. Let me not overreact, but yeah, there are a lot of blockchains being built on a daily. A lot of blockchains, like I heard of recent, like few blockchains that just came out, and the issue with that is because there's no universal standard for building blockchains, and that's not a future that we want. Complexity in implementation, yes, it's a good thing, right? They're trying to solve a particular problem, but it is also very complex. For example, Stacknet is very complex because it's working on its own. We are still figuring out a way Stacknet can work with other layer 2 blockchains and other layer 1 blockchains as well. But recently there was a breakthrough where Stacknet is now interacting with Bitcoin, which is a very good thing, right? So we are moving somewhere. We're moving somewhere. So complexity in implementation is also another issue. So latency and scalability issue here. Some blockchains are slower than other blockchains, and some blockchains do not offer the same scalability issue that other blockchains offer. So we also have economic and governance disparities. So there are some blockchains that work with governments. There are other blockchains that do not work with governments, and sorry, not that, DAOs, yes, talking about DAOs. So governance, talking about DAOs. So when you talk about DAOs, we're also talking about governance as well. So some blockchains have different DAO regulations and DAO rules that they follow. So some blockchains may not be able to, work with that. So lack of collaboration as well. Blockchains do not collaborate. Yeah. So how does the Superchain achieve interoperability? The Superchain has something called the Superchain registry. This is an information hub providing thorough, actionable information for every chain on the Superchain. A sec. All right, so providing thorough, actionable information for every chain on the Superchain. So this registry would provide a source of truth for the configuration, security, and the policy choices made across the Superchain. So you have a single registry that provides all the information you have of every chain. So basically bringing all these chains into one registry, right? One document. You're putting them in one registry where everybody can access what is happening on that chain and everything that's happening on that chain, the markets of that chain, the health of the chain, the everything that the chain is currently doing. Yeah, you can access that. So let me open this so I can show it to you guys later, so I can explain that. All right. Moving forward, we also have block space charter on the Superchain. So this is a framework. It's very powerful actually. So this is what gives Optimism the governance the tools to make certain decisions about protocol upgrade. Because I know when I heard about this, I was actually very skeptical as well, because this is one blockchain or one entity deciding how the standard of building blockchains can be, and there can be some certain disagreements with some people disagreeing what happens and stuff like that. So there's a governance that makes informed decisions on what happens on, like, the protocol, the upgrade to the mechanism being used, the OP stack, everything that's happened. There's also like a governance for that. So that's called block space chatter. So this takes into account the potential differences between different kinds of chain, because different kinds of chain have different uses. So I would also emphasize that most blockchains that can be a part of the superchain are mostly, for now, they are optimistic rollups, right? That's the rollups that can be a part of the superchain at the moment. So advantages of building on the superchain, and for example, a chain like Leaks, there are a lot of advantages of building on Leaks. So all chains building on the OP stack share a security update. Where one project finds a vulnerability and patches it, all the other chains get the patch and upgrade. So for example, Leaks finds something wrong with the OP stack and they share what they have done with the Superchain team, and they decide, okay, yeah, this is good. So sorry. So that patch is being added to other blockchains, like for example, Base, Celo, and Scroll, and the others on the Superchain. So they have a shared code base that ensures that these projects are connected and interoperable. So Leaks is one of the projects on the Superchain and some other things. So let me just share this. So this is the Superchain ecosystem. These are all the chains on the Superchain. So you can see them. We have the Open Mainnet, we have Inc, Unichain, Sunia Mode, Zora, a lot of them. We have Base, we have Leaks, we have Ship. This is a new one actually. We have, so it's very, I'm very happy seeing new chains using the OP stack, because it shows that okay, new blockchains are using the same formats, which should allow us to achieve interoperability on the blockchain. So from what I've said, what do you think about interoperability? Do you think this is something good, and how do you think interoperability can further help us? So you can type your answers on the chat. So with more regulations, and decentralized blockchain would still be decentralized, but they would have to respect more laws, I guess. Yeah, that's true actually. Nice contributions. So what are your thoughts on blockchain interoperability, and how do you think that can help us? So there's a little hands-on demonstration that we need to do on installing a MetaMask wallet. So I'm just going to do that real quick. All right, so setting up a wallet like MetaMask. So first you need to do is download and install MetaMask as a browser extension. We are going to be using browser extension for this class, for this bootcamp, because you need a laptop to be able to perform and write smart contracts. Makes it very easy. So let me just go through that. So do not waste time on that. All right, so loading up. So we are going to be adding so creating a new wallet, security, seed phrases, so that so let me see. So for this you have this step 4 is very important. So it gives you a good way to get leaks faucets. This is a very good way for you to get the leaks test ETH. So it's just a way for you to have test tokens to perform certain transactions on the blockchain. So let me just do that. Okay.
So on the side of Destrupack, all are already MetaMask. Just yes, they need to add the Lisk RPC network.
Yeah, definitely. So you need to add the leaks network to that. That's partly part of the assignments.
Are you
Just going
using
to
Chain ID or
you said?
are you using Chain ID to add it?
Yes, they would have to do that, but there is an alternative option using chain list. Sorry, chain list.
Yeah. When I said sorry, chain list, I wanted to say chain ID. Sorry, sorry, chain list. Yeah.
Yeah. So that is part of the assignment actually. So I'm not going to go too deep into this. I'll not do all the assignments, but I'm just going to install it so you have an idea how to do that on your end. So I just clicked on add to extension. So it's currently installing. So let me just share. Give me a sec. Okay. So this is the assignment. So the assignment tells you to install MetaMask on your computer and add the following network. So you have to add the leaks mainnet, Sepolia testnet. So you have to submit a screenshot showing that you've installed, you've added the leaks mainnet to your MetaMask and also the leaks Sepolia to your MetaMask. So this is a way you can add the networks. So this is chain list and how you can do that. So I think it's okay. It's still installing. It's still installing. So if you have any questions about the assignments, definitely drop your questions on the Telegram and we would respond to it.
It's like a softer
Alright.
homework. That's fine, I think.
Yes, yes. Yeah. All right. So that is it. So get started. Right. They want me to be sure that I've read it. I have. All right. So creating a new Watermarks wallet. So you set your password. Set a password that you can remember so that it will not be something that you forget, because if you forget it, you will not be able to access you can actually using your seed phrase, but it's just easier if you remember. So this is step one. It's actually very straightforward. um yeah, this is don't risk losing your funds. Protect your wallet by saving your secret recovery phrase in a place you can trust. It's the only way to recover your wallet if you get locked out of the app and you get a new device. So if you forget your password, your secret recovery phrase is a way for you to get this. If you folks I know have lost a lot of funds because they lost their secret recovery phrase because they forgot where they stored it, so they lost it. So please save it in a very secure place that you'd know. So save your secret recovery phrase. So you can just tap to review your secret recovery phrase and see. You said make sure no one is watching my screen. So I'm just going to share another slide. So that is a way for me to secure. Let me be sure that you guys are not seeing. All right, yes, I can go ahead and do it. Have to be very careful. All right, so yes, continue. They're telling me to save it somewhere, and give me a sec. Just going to save it somewhere that I can access it. Why is this? All right. Oh, okay. Let me share this.
It's
So
short.
your secret recovery is also a seed phrase or a mnemonics. So it's a set of words that lets you access and control your crypto wallet. So to move your wallet to MetaMask, you need this phrase. So anyone with your secret recovery phrase can take all your money, confirm transaction, change your login information. So anyone with your secret phrase has access to your money. So if you allow anyone to have access to your secret recovery phrase, that just means that you are giving them access to your money, to all your money, and to all the wallet addresses you're going to ever create using that wallet. You're giving them everything. That's bad. Oh, no, no. Oh, I already did it. Let me just share this. back. So this is a wallet I'm not going to use, so it's fine if you see it. Just want to save this somewhere so I have access to it. Just give me a sec so I save it so we can continue. So I have to save it. I don't know why there's not a way where I can just, oh yeah, I can just do this actually. Just copy everything. Yes. All right. So you have to confirm your secret recovery phrase. So you have to select the missing words in this order. So the first word was wisdom. Oh, I think it's not allowing me to type because I'm sharing my screen. So let me share this tab instead. But this is a nice, okay. It's not typed, so I just have to select.
So
I just have to select the.
what's the difference between the two faucet sources? It's just like if you are stuck with one, you can split with like check with the other one. And it's weird that Chainlink is not working on your side, Nani. On my side it's working. Weird.
No, thanks. All right, so our wallet is ready. Installation is complete. Solana is now MetaMask. That's awesome. All right, so this is my wallet successfully created. I'm done creating it. Yeah. So let's go over to the last topic for the day. So we'll not spend too much time. We're almost done. I know some of us are tired already. All right, so moving forward, technical writing. What is technical writing? Technical writing is an art of breaking down complex technical concepts into simple, understandable, and actionable content for specific audience. So it includes documentation, APIs, SDK, tutorials, how to guide. Just to ask, please confirm that everyone has marked their attendance. So the attendance is very important because it's okay, yeah. We have 51 people have already marked their attendance. This is good. All right. So the attendance accumulates to the overall points you get. And we have something for the best student in the bootcamp. So endeavor to mark your attendance on time. Very important. All right. So technical writing is, yeah, so it's a means for you to write documentation, tutorials, how to guide, developer blog, articles, release notes, and white papers. These are also called technical writing. So why should you care? You are a developer, why should you care about technical writing? So writing forces you to really understand what you are building. So if you write, you understand what you build more. It also makes it better, makes you better as explaining. So you understand how to explain your code, explain ideas to your teammates, and to anybody that needs mentorship from you. So it's a good way for you to understand how to explain your concept. So there are some of you that are building matters projects that are very good. So you need this knowledge of technical writing to be able to share what you are building and for people to be able to relate and understand what you're building better. So visibility, so it boosts your credibility and presence in the tech community, because there's a lot of articles that I've read while I was learning. There's a lot of articles I've read, and a lot of people have read my articles as well. And that's because I was sharing what I was learning. So as you're learning, please endeavor to write about what you're learning. After this class, you can write an article about how the class went, what you learned, and stuff like that. So you can post your article anywhere you want. So, and there are blog websites that you can use. You can share on Medium, you can share on any blog website. You can also share on X as well, on LinkedIn. That is also a means of technical writing as well. So that helps you. And another way is giving back to the community. The community has helped you in any way. This is a way for you to give back to the community. and help any developer that is coming up. I know you may think you are still learning, but you have a lot of knowledge to give, and than you may even realize. So how to get started with technical writing? What you need to do is pick a topic, right? Start small. You can explain a bug that you solved, let's say a tool that you use, a concept that you learned. So we spoke about cryptography today. You can just write an article on how you understood cryptography. This would also help you to understand cryptography. You tend to do research. You tend to do a lot of research, a lot of findings. You get a lot of findings from your research, and that solidifies your knowledge on cryptography. I think you should try it. So for those that are very interested in cryptography, or the mechanism in which addresses, keys, public addresses, private keys are being, generated, you should check it out. You should try it, and write about it. That would help solidify your knowledge. And then if you're writing, you should know your audience. If you are writing for beginners, your tone should be beginner friendly. If you're writing for intermediate devs, then you would just assume that I'm writing for devs. I already understand this beginner concept, so I do not need to be that to go into deep into fundamentals and stuff like that. So just understand the audience that you are writing to, and then use a simple structure. You have a title, you have an introduction. An image also helps. Images also helps portray your points. You can have cover images, you can have images. Infographics as well also help. So infographics are just images in your blog body that explains what you are saying, what you are explaining to your users, and stuff like that. So you also have a summary as well to explain all the concepts that you have learned as well. So you can choose a platform. You can write on Hashnode, you can write on dev.to, you can write on Medium as well. So lastly is to get feedbacks. If you have friends or mentors around you, you get feedback from them. So the assignment I'm giving you has to do with technical writing. So that is also a way for you to get feedbacks. So I'm going to give feedbacks on the assignment, so you can definitely use this as a means to do that. So this is the task. You need to write a beginner-friendly technical article on any topic that we've covered today. Pick any topic that we covered today and write about it. So keep it simple, beginner-focused. Include a lot of images, screenshots to help understanding of anyone that is reading your blog. So you can publish your articles on any of this platform, and submit your article link along with the MetaMask screenshot. So you need to submit a screenshot that you have installed MetaMask, and also that you have added all these networks. Then, so if you don't do this, you won't be able to follow the next class. So please try as much as possible to complete these assignments. They are very important, so you can follow along because the next instructor is just going to assume that you have done the assignment and you understand. So to aid, for those that do not really understand how classroom works, so let me just do a test assignment for you to understand how it works. So you can submit here. So you submit a test document. This would not be graded. So this is just for you to understand how submitting assignment works. And if you make any mistake, I'm going to correct you. So do this, and yeah. So you can just submit any test document and write anything you want in it. I think I should add it to the assignments column. All right, this works. All right, so this is here. So test assignment. So you can just submit any documents. So it would help aid submission assignment. So yeah. that's all for today from me. And the summary of what we spoke about today is understanding of the blockchain, private public blockchain consensus mechanism. We also spoke about private keys and public keys and how they are being generated. We also explained the Superchain, setting up a wallet, and also an intro to technical writing. So if you have any questions, you can ask on the comment section, and I'm going to respond to it. Yeah. So out of curiosity, thank you guys for the emojis. Thank you. So is there anyone that wants to submit their assignment using the tests assignment? So we just do a test round just to be sure that you understand how to submit an assignment before the main one, so you don't make any mistakes. Is there anyone that would like to do that? You can just raise up your hand so you can share your screen and do a test run. That's if you're on Classroom. You need to be on Classroom to do that.
Everyone is
Any-
on class right now, by the way.
Oh, okay, awesome. So anyone wants to do that, you can just raise up your hand. So you can just share your screen and do a demo on how to submit an assignment.
Je did say okay, but I don't know if it's for that. Oh, again.
Okay, awesome. So you can share your screen, share your classroom. So you do a test run on how to submit an assignment.
Okay,
You
I'm
stop
not
sharing.
sure if I can. Okay, guys, I have a lot of things.
Is she allowed to share?
Yes,
It's,
but hold on, I'll have to put
Okay.
to find it. And then this one. Which URL is it again? Google Classroom.
share the link again, you mean?
Yes.
Yes. Right.
Okay.
It's
It's here actually.
you got it. Okay.
Yes. You can see this one, right?
Yeah.
Okay,
Yes,
so add or create.
So
How do I submit a test document? I just add here, right?
yeah, you can add or create.
Okay.
So I click on that button.
Yes.
Yeah.
And then I just send a link, for example, or a document.
Put a screenshot. I don't know, something like this. Take a screenshot.
You can put a document as well. The document is also use a doc.
Okay.
So in the doc,
Document.
add screenshots to the MetaMask and also a link to. So click on create docs.
Oh, interesting. I did click add or create, and then
So
if I
inside the
do
document,
create,
you can now add the link to the blog and the screenshots to MetaMask.
okay. So I think for here, I can just get this because my MetaMask is in here.
Yeah.
So if I do this screenshot and send this.
Thanks. Oh my god. Hello?
Yes.
Oh my gosh. My network is misbehaving a bit. Oh.
Yeah. Victoria is frozen.
Is it working?
Put.
Okay. Sorry, I'm back.
Okay.
Okay, so it should be in here now, I think. Yeah, because I pasted this screenshot. Can you see?
Could you hear us?
This one, right?
If you put turn in.
Oh,
Turn in.
turn in. Yeah. Turn in. Okay.
Yeah. I will check because I
I
have access.
can unshare and then stop
So this
presenting.
assignment. Yes. We got it. We got it. We got it. All right. Perfect. All good.
Okay.
Thank you for volunteering as usual.
Yes.
Yeah. All right.
It's 7 o'clock.
Yeah, it's 7 o'clock. Indeed. It's the first time with 2 hour session. So as we you can see, it's like a real boot camp. This time. And you have to know that a couple of boot camps is like 2 hours by day during 8 weeks. So it's like a lot of consistency. But this time it's just 2 days by week, so that's fine. All right. So thanks a lot, Victoria, and also ETT for helping with question and presenting this first session. Tomorrow is going to be about Solidity basics. So yeah, not tomorrow, sorry, on Thursday. And yeah, so see you on Thursday, and really take care. Make sure you are completing the homework on your side. And yeah, all good.